For the rest of this chapter, we're going to study the layers of the sun. We will start in the very center of the sun, where we have the core, where the fusion takes place that we just talked about. And then we'll talk about each layer as we move up and away from the core. Looks like there's a layer here that's got little squiggly lines in it. Something's coming out of the core, taking heat up to the surface of the sun. And when that heat makes everything really hot up here near the surface, it looks like gases come up and rise and fall back down. These are all going to be considered to be different layers of the sun because something different is happening in each one. And you should be expected to answer questions which say, what is special about that particular layer of the sun? Is there a reason why it has that particular name? What's happening in that layer of the sun? Can I see something in that layer of the sun that I don't see in some other layer of the sun? So be prepared to study these layers with that idea that you're going to be asked, how do I say something special about each particular layer of the sun? Once we get up to this part of the sun that we actually see when we look at the disk of the sun, we're going to say that's the edge of the sun. Even though the sun is a giant gas ball that's burning, we would not be able to stand on its surface because it's gas. It's not solid. But we'll still say that's the edge of the sun, and above that are layers of atmosphere. Again, those count as layers where I would say, do you see something there? What's special about that layer? So to begin with, we talked about the nuclear reactions in the core of the sun. That's where it is hot enough for the nuclear reactions to take place. That's where you can get hydrogen smashing together so that it can merge and become helium. The temperature is 15 million Kelvin in the center of the sun, in the core. If we move away from the core as we go through this lecture, it's reasonable to expect that when you move away from the source of the heat, you're going to have a decrease in temperature. So here we go on to the next layer. The radiation zone, it has a temperature of only 7 million Kelvin. In the radiation zone, those squiggly lines we saw in the previous diagram were representing gamma rays. Remember, gamma rays are produced in one of the steps of the fusion process for the nuclear reactions in the core. So those gamma rays are trying to escape at the speed of light. Remember, they are part of the electromagnetic spectrum. So they're trying to escape at the speed of light from the core. But they keep colliding with lots and lots of particles in the radiation zone because it's so dense. You can still have collisions with other sorts of atoms and free electrons and things that will temporarily absorb the gamma ray, but then come emitted out again. So the gamma rays will bump into something, and when they're re-released, they actually leave behind some of their energy in the thing that temporarily absorbed them. This provides heat to the radiation zone. So the radiation zone is getting heated up by gamma ray radiation. And those little particles that keep absorbing and re-releasing the gamma rays can redirect them and delay them so that even though they're trying to escape at the speed of light, by one estimate, it could take gamma rays 170,000 years to make their way out of the sun and get all the way up to the surface. That's a lot of delays and lots of collisions for something that's trying to get out at the speed of light. Then we come all the way up to the convection zone, which gets up to near the surface of the sun. As we've moved away from the core, we went from 15 million Kelvin to 7 million Kelvin, and now we're dropping down to 2 million Kelvin as we get near the surface of the sun. The convection zone is named because the process of heat carried through convection is happening in this region of the sun. Hot material is getting heated up from all of this heat that's coming up from the core, and when it gets hot, hot gases rise. So that rises up to the surface, releases some heat in the form of radiation and also in the form of particles which become solar wind. And then, since it released some heat, it's a cooler gas and it's going to sink back down. And then it's going to be near the hot portion again. So it's going to heat back up and rise back up and release heat and then sink back down. And that's how convection is working. Just like boiling water, you take the hot part that's on the bottom of the stove, the water would rise up, release some steam, and then cool off and go back down. And that produces a bubbling sort of effect when you're boiling water on the stove. So we would expect to see that same kind of thing happening here near the surface of the sun, where the heat is coming up with gases that release the heat and then go back down. So that's the process of convection. The hot material rises, cools, sinks back down, heats up again, rises up again, and repeats.